Hello everyone. I wanted to do a video about BDD. BDD stands for Behavior Driven Development. So it's a testing paradigm that allows us to write test cases in more English-like scenarios and implement them in any programming language of your choice. So this would be a video about BDD and how to implement it with Python. So in this video, we'll be learning about what is BDD, how to write BDD scenarios, how to implement steps, and again, we'll be taking example of Python in this case, and how to run BDD test cases and generate reports. For simplicity, I've actually made use of a calculator app. It's very easy to understand and it's very easy to explain different scenarios mean as part of the calculator. And you can find this code base, including the calculator code base, at this location. It's github.com TFIO, that's our company name, and BDD Testing Quickstart. All right, so what is BDD? So one of the main challenges that BDD tries to solve is the communication between business teams and tech teams. So usually what used to happen was business teams has a whole bunch of requirements. They explain it to the tech teams to get those implemented, but there isn't a clear language between both of them. It's more descriptive. So BDD tries to change that paradigm, and it tries to make the communication between business and technology teams more trackable. It's determined as part of different scenarios that different user behaviors that user can specify. And the tech team, comes to know about these requirements in a well-defined structure, and they know what exactly to implement. So that's sort of the whole high-level idea about BDD, and we'll be going into a little bit more examples to give a little bit more information and clarify what that means. So continuing on, what is BDD? So it's a framework for communicating business requirements clearly to development team. Business requirements are codified through different scenarios, and scenarios are written in steps, and these steps are the ones which are actually implemented in any language, and they basically form the basis of your test cases. So there is, because these scenarios are written in sort of English language, it becomes a common language between developers and business groups. So before we actually jump into an example, I just wanted to show how a BDD hierarchy looks like. So in BDD, we talk about features. So these are like really high-level features, things such as login, registration, dashboard. Those would be the high-level features. So a high-level feature is sort of a vertical module which implements a whole bunch of scenarios within itself. Individual scenarios within this feature are basically different user behaviors that can be simulated. Steps are individual steps of these scenarios. Now let's take an example and let's talk about this in a little bit more detail. So let's say if I have a calculator application and if I want to test it, so what are the different types of feature scenarios and steps can we write about it? So with the calculator, I should be able to add. So let's say if I input 2 plus 3, then I expect the result should be 5. So this is a scenario which is written from a user's perspective or from a business perspective. This is what the business people want from the development team. So I've written like a few scenarios here: addition, subtraction, multiplication, and multiple operators. Let's say addition plus multiplication. So for addition, I have 3 steps. So all the scenarios at least have one or more steps, and these steps are written in the form of given, when, then. So given the calculator app is open and I input 2 plus 3 into the calculator, then I get the result of 5. So this is a scenario. These individual steps that I mentioned are the individual steps within it. So similarly for subtraction, we have a different scenario. Multiplication, we have a different scenario. And for different operators, we have another scenario. You can go ahead and write one more scenario. And this could be scenarios such as negative numbers. Given a calculator app is run, when I input let's say if I just input a negative number, -1, -3, or let's say if I add a -3 + 5, then I get results 2. And the 2 will put it in quotes. Anything that is a variable is usually put in quotes so that I can easily capture it and write a different function for it. So let's run this scenario and see what happens. So I've already implemented these scenarios, so you might already see the results, but let's see how to. So as I ran the scenario, all the steps here are implemented and I get the results. So this is how a typical test result would look like with BDD. Let me make it a little bigger. So I ran this command, behave calculated of feature, and it ran individual scenarios. So it ran addition, subtraction, again, more addition, more subtraction, multiplication, multiple operators, and negative numbers. It's from here. So yeah, it ran addition, subtraction, multiplication, multiple operators, and negative numbers. And these are the results which we get with that. So how did it figure out like what functions to run and how did it get the results for us? So let's actually take a step back and let's uncomment out what I've implemented so far, or comment out what I've implemented so far. And let's run this again and see what happens. So yeah, at this point, like from a presentation point of view, we are here, we looked at what a feature file looks like, what a hierarchy looks like for a feature file. The next step is we run this, behave. So now, because I've commented out the actual code which implements this, so it's giving me an error and it's saying all of the scenarios have failed, and it's giving me some information here about how to implement these functions. So these are the scaffolds for implementing the step functions. Right, so this is calculator.feature, because this is all commented out. So once we actually go ahead and run this, we get the scaffold. So we can take the scaffolding code that's been provided to us, copy it over like this, and then implement it in a steps file. So let me just start it in a new steps file. And I can name it anything I want. Behave doesn't really care as long as it is within the same directory as the feature file, or a peer directory of the feature file, or the parent directory of the feature file. So yeah, it's able to find out how to find where the steps are located and how to implement them. So I just copy pasted all the given when then statements that I had gotten from the scaffolding. In order for me to actually implement a behave feature, I need to import given when then from behave package. I also need to import actually let me import the run function from the calculator program that I have, and this is the actual function which does the calculation for us and gives back the results. And it's located here. Actually, it's also part of the code repository, and you can go take a look at it and see what it is doing. So if I run this manually, I take an input from the user and I run it through this run function, which internally takes care of normalizing the string, finding out whether it is valid or not. And until there are some operators available, we keep iterating through those operators and the left and right side of the equation and then calculating the results. So yeah, this basically does the actual calculation part. And we're going to start writing some test cases for this. So as you can see, there are a lot of different steps, but all of them are taking different types of input. Like there is a when step for I input 2 plus 3 to calculator. Then there is when step for I input 5 minus 2 to calculator. So we can combine all of this and actually take it as a variable. So let's call this variable as input. So if I want to take a variable from a regular expression, which is the step, then I have to do it like this. So I have to put it in curly braces and then give it as an argument to the implementation function. So in that case, I don't really need to implement this guy because this is already implemented above. So this one also, instead of taking the result here, let me take it as the output and give it as an argument here, out. And this one is similar to the one above. This one is also similar to the one above. And all of these actually turn out to be the ones above. So in a sense, I only had to write 3 different steps here. And these 3 different steps form the basis of our test feature. So all of these different scenarios were basically written with 3 different steps. And once I've implemented these different steps, and the implementation is fairly straightforward. In this case, I'm only calling the run function for this implementation. So for example, in the case of calculator app is run, I'm not really doing anything because as part of this example, we don't have to do any given statement. We're just implementing when and then. As part of when, I'm calling the run function with the input string that is passed to us and storing the result as part of this context variable. So I'm storing it as part of context.result. And as part of the output function or the then statement, I'm actually asserting the result is same as the output that I expected from this string that I got here. Okay, so let's go back here. Let's comment this guy out because we already have the other code, and let's try to run it again. And as you can see, after I run that, all the results are available here. It says one feature passed, 5 scenarios. It had 5 scenarios, all of them passed, and then we had 15 steps, all of them passed as well. So this is one easy way to write test cases based off of reusable test steps and scenarios which are already available for us. So the slide deck also mentions how the implementation code is and how the results are. That's it in the slide. Thank you very much.